4 400 gig ports in a 1U switch sounds ridiculous until you look at what actually replaces it. This isn't about raw speed. It's about fixing network problems that show up way earlier than what people expect. This is the brand new MikroTik CRS804 DDQ. It's designed for AI workloads, storage fabrics, and high-speed core or aggregation roles without the size, noise, or power draw you'd expect from the 400 gig gear. But here's the problem. Networks don't fail because they're slow. They fail because traffic patterns change faster than the design does. That change isn't theoretical. It shows up as traffic moving in ways the network was never designed for, like GPU workloads, storage traffic, east-west flows. You start stacking switches, adding links, and suddenly your network works, but it's fragile. Now, let's take a look inside the CRS804. Inside, you're looking at a Marvel 98DX7335 switch chip with a quad-core 2 GHz ARM CPU, 4 GB of RAM, and Router OS version 7. That combination is what allows this thing to push full wire speed layer 2 traffic without needing loud cooling or massive power budgets. This isn't a general purpose router trying to do everything. It's a purpose-built switch that optimizes to move a lot of data very predictably. The interesting part isn't just that this has 4 400 gig ports. It's how flexible those ports actually are. Each one is built from 8 independent lanes, which means you're not locked up into 400 gig from day one. You can run native 400 gig split ports into 2 200 gig links, or even break them down further into 100 or even 40 gig connections with the right breakout cables. That's what makes this useful early, not just later. You can drop this into an existing network, clean up the core, and scale the speeds over time without replacing the switch. Now, 4 400 gig ports are the part that makes people stop and ask, who is this actually for? And the answer isn't massive data centers. It's smaller networks that are hitting the same traffic problems, just at a different scale. Each one of these 400 gig ports is built from 8 independent lanes. That's what gives you flexibility. You can run native 400G, split the port into 2 200 gig links, or break it down further into 100 gig connections without replacing the switch. That means you can deploy this today for aggregation or backbone roles, and grow into higher speeds later without redesigning everything. All-flash storage fabrics are another good fit. They generate a lot of simultaneous traffic and fewer hops with wider uplinks that make a real difference. It also works well as a compact core or spine in enterprise and edge networks, especially when a traditional 400 gig gear is too large, too loud, or too expensive. Now, this is not a switch for access ports or general endpoint connectivity. If your network is mostly user devices, cameras, or low-speed edge traffic, this is the wrong tool. And if you don't clearly understand how traffic moves through your network, adding a 400 gig port won't fix a bad design. This only makes sense when you know exactly what problem you're solving. If you found this video helpful, please like and subscribe. And if there's a specific product you want us to review and break down, let us know in the comments. Thanks for watching.